explain about the question number 1. So the question is, consider the function y equal to fx equal to 2x power 3 minus 9x power 2 plus 12x and minus 4. So find the interval where f is increasing and decreasing. Be sure to construct the sign diagram to support your conclusion. So for the first step, we have to differentiate the fx. So we got the f prime x is equal to 6x power 2 minus 18x plus 12. So for the step number 2, we have to find the critical points where we have to equal to 0 and solve for x. So the 6x power 2 minus 18x plus 12 equal to 0. And we divide the entire equation and we factor the quadratic equation. So we got the x minus 1 and x minus 2 equal to 0. So for the first x, we got the x minus 1 equal to 0, so x equal to 1. And for the x number 2, we got x plus minus 2 equal to 0 and x equal to 2. So the next step, we can use the sign diagram and how we can determine the interval. So the critical points, we have x equal to 1 and x equal to 2. So we divide into the 3 interval where we got the negative infinity 1 and 1, 2 and 2 infinity. So for the each interval, we have to test value. So for the first interval, negative infinity 1, we test value, we put x equal to 0, and then we got the answer is 12. So that means the sign is positive and conclusion is increasing. And then the interval number 2 is 1, 2. The test value, we put x equal to 1.5, and then the answer we got negative 1.5. So the sign is negative and the conclusion is decreasing. And then the last interval, we have 2 infinity. So test value, we put x equal to 3, and then we got the answer is 12. So that means the sign is positive and the conclusion also is increasing. So for the answer, we got the function fx is increasing on the interval of negative infinity 1 and 2 infinity. And the function of fx is decreasing on the interval 1, 2.
I will be presenting question 1b and question 2b. Now question 1b, face the following demand function, BEEQK equal to 100 minus 4Q. 1. Derive the total revenue function. Second question, determine the concavity of the revenue function. 3. Find the output level of which total revenue maximize and interpret the result economically. So for first question, we use total revenue function. RQ equal to P times Q. Then we enter the amount. RQ equal to 100 minus Q times Q. Then we got RQ equal to 100Q minus 4Q squared. So for second question, we need to determine the concave. So RQ equal to 100Q minus 4Q. Change it into first derivative, so it becomes r prime q equal to 100 minus 8q. Then second derivative, it will become r prime q equal to negative 8. So negative 8 less than 0, it means the revenue function is concave downward. Question, we need to find level output. So r prime q equal to 100 minus 8q, r prime q equal to 0, 100 minus 8q equal to 0, 8q equal to 100. So we got the q is 12.5. When q equal to 12, we got 4, which means it's increasing. When q equal to 12.5, we got 0, which means it's constant. And when q equal to 13, we got negative 4, which means it's decreasing. In conclusion, total revenue is maximized when the output level is 12.5 units. At this point, any further increase in production would cause the total revenue start to decrease. Next question, 2a. The total cost for a company is given by the equation TC equal to 100 plus 2Q plus 0.1Q squared, where Q is the quantity of units produced. So, first question, calculate the marginal cost is increasing for the company. Second question, determine if the marginal cost is increasing or decreasing as production increases. We need to find marginal cost, so we used first derivative. TC equal to CQ equal to 100 plus 2Q plus 0.1Q squared. So MC equal to C prime Q equal to 2 plus 0.2Q. For second question, we need to determine whether marginal cost increasing or decreasing. So second derivative, C prime Q equal to 0.2, which means 0.2 more than 0. Since 0.2 is positive, the MC is increasing as production increases.
Next, I will explain on how to get the answer for question 2b. So for question 2b, there are two parts that we need to answer. The question is, the price function for a product is given by P equals 100 times E to the power of negative 0.05 Q, where P is the price per unit and Q is the quantity of output sold. So for part 1 of the question, we need to find the quantity that maximizes the revenue, and for part 2 of the question, we need to determine the intervals where total revenue is increasing and decreasing. So in order to solve part 1 of the question, for step 1, we need to form the total revenue function. As we know, total revenue is calculated as price multiplied by quantity. So total revenue equals 100Q times E to the power of negative 0.05Q. This gives us the total revenue function, which depends on the level of output produced. So for step 2, we need to differentiate the revenue function. In order to find the quantity that maximizes revenue, we take the first derivative of total revenue with respect to Q. Using the product rule, the derivative of the revenue function becomes 100e to the power of negative 0.05q minus 5q times e to the power of negative 0.05q. Next, we factor out the exponential term. So this will give us e to the power of negative 0.05q multiplied by the bracket 100 minus 5q. So for step 3, we need to find the revenue maximizing quantity. In order to do this, first, we need to set the first derivative equal to 0. Since e to the power of negative 0.05q is never equal to 0, we only solve the expression inside the bracket. So 100 minus 5q equals 0. Solving this equation gives us q equals to 20. So in conclusion, this means that total revenue is maximizes when q is equal to 20 units. And for part 2 of the question, we need to determine the increasing and decreasing intervals. So in order to determine where revenue is increasing and decreasing, we need to examine the sign of the first derivative. So when q is less than 20, the expression 100 minus 5q is positive. Therefore, total revenue is increasing. When q is greater than 20, the expression becomes negative. Therefore, total revenue is decreasing. So in conclusion, total revenue increases when output is less than 20 units. Meanwhile, total revenue decreases when output is greater than 20 units. That's all from me.
I will now present question 3, which focuses on profit maximization for a local manufacturing company. We are given two key functions. First, the demand function, Q minus 90 plus 2P equal to 0, and the second is average cost function, AC equal to Q square minus XQ plus 57 plus 2 over Q. Our task is first to find the value of Q which the profit is maximized, and second, to prove this result using the second order condition. For the one Roman question, we need to find the profit function first, which is total revenue minus total cost. So we must first determine TR and TC. To find the TR, we rearrange the demand function to find price P. So we will get the P equals to 45 minus 0.5Q. Multiplying this by quantity Q gives us a total revenue of 45Q minus 0.5Q squared. Next, we find total cost by multiply the average cost by Q, and we will get the Q power 3 minus XQ squared plus 57Q plus 2. Now, revenue minus cost, which is 45Q minus 0.5Q squared minus Q power 3 plus XQ squared minus 57Q minus 2, we will get the profit function negative Q power 3 plus 7.5Q squared minus 12Q minus 2. Then, to find the maximum profit, we need to find the first derivative, which is P prime Q equals to negative 3Q squared plus 15Q minus 12. Then, setting it to 0 and factorize it. So, we will get two critical values, Q equals to 1 and Q equals to 4. Now, we must prove which value maximize profit using the second order condition. From the first derivative function, we get the second derivative, which is negative 6Q plus 15. We test both points. At Q equals to 1, we sub the value 1 into the second derivative function, we get the positive 9, which is more than 0. It means the curve is concave upward, so this is a minimum point. At Q equals to 4, we get the negative 9. Because this is less than 0, the curve is concave downward, and this is a maximum point. So using the SOC, we prove that profit is maximized when Q is 4 units.